class. Good evening everyone. Welcome once again to today's class, and as you all know, today's class is your Umang CBSE grade 9, and today we'll be discussing the topic polynomials. And the subtopic for today's class is a very important topic from this chapter, that is your remainder theorem and factor theorem. So I'll be explaining this chapter, this theorems to you today, and we'll be solving some basic questions related to it. And after that, we'll be moving ahead with in the next session, I'll be telling you the more important questions related to this chapter. Okay. So that is what we are going to discuss today. So let us start the class. I hope all of you are ready. So first thing, if I want to discuss something with you, that before we go for the remainder theorem part, let us just quickly understand what do you mean by the value of a polynomial. Okay, so suppose the question is find the value of polynomial 5x minus 4x square plus 3 at x is equal to 0 or x is equal to minus 1, right? So it means that suppose if it is a polynomial, now many of you must be having this doubt that sir, sometimes you will write px. What do you mean by this px? So this px means nothing but p stands for polynomial and this bracket x stands for the variable. So px means a polynomial in the variable x. As simple as that. Got it? So I will say suppose this px is given as 5x minus 4x square plus 3. So if I want to find out its value at x is equal to 0, so in this part, wherever I will find out, wherever x is present, at that place I will write 0. So it will become P0 is equal to 5 into 0 minus 4 into 0 square plus 3. So what you'll be getting? You'll be getting 5 into 0 is 0 minus 4 into 0 square is also 0 plus 3. So you got P0 at 3. P0 is equal to 3. So this, when I write now P0, it means value of the polynomial. P stands for value of the polynomial when inside the bracket you have 0 when x is equal to 0. So if I have given you Px and I tell you what is P0, it means value of the polynomial at x is equal to 0. Got it? Similarly, if I write what is P of minus 1, directly you can say that value of the polynomial at x is equal to minus 1. So here in this part, suppose P0 is equal to 3. So the value of the variable is 0, but the value of the polynomial is 3. So this is the difference over here. Okay, value of the variable is 0 and value of the polynomial is 3. Similarly, in the second case, value of the polynomial is, we will be finding out, and value of the variable is minus 1. So in place of x, wherever x is present, I will write minus 1. So 5 into minus 1 minus 4 into minus 1 square plus 3. 5 into minus 1 is minus 5. Minus 1 square is 1. 1 into minus 4 is again minus 4 plus 3. So minus 5 minus 4 is minus 9 plus 3 is minus 6. So the value of this polynomial at x is equal to minus 1 is minus 6. Got it? So there are two different things. One is value of the variable. That means what value of x you are putting in this part. What value of x you are putting in this polynomial. So in case 1, my value of the polynomial, value of the variable is 0, and at x is equal to 0, value of the polynomial P0 is equal to 3. Value of the variable here is minus 1, and the value of the variable at the value of the polynomial at x is equal to minus 1. So P of minus 1 is minus 6. So P of anything is the value of polynomial at x is equal to something. So suppose if I write P of A, it means what? Value of polynomial Px at x is equal to a. That is the meaning of this part, right? So now don't be confused about this part, right? Now let's move to the part of your remainder theorem which we have to study now. Now the remainder theorem, before we go for the remainder theorem, first let us understand that why remainder theorem works, and then we'll understand that how do you solve the remainder theorem. So you know beta that if I divide suppose 25 by 4, so you'll know 4 6 are 24 and remainder is 1. So in this case, your 25 is your dividend, this 4 is your divisor, this 6 is your quotient, and this 1 is your remainder, and this one is your remainder. Okay, so and you also know that the remainder always has to be less than divisor. The remainder cannot be 5. Okay, you cannot get remainder more than the divisor, correct? So we know that the remainder should be less than divisor. Now there is a relationship between all these four quantities. It is not dividend, it is D. Okay, dividend. So the relationship between these four quantities is dividend is equal to divisor into quotient plus remainder, right? This is the relation which all of us know. For example, for this part, what it will be? So I can say 25 should be equal to 4, divisor is 4 into quotient is 6 plus 1. You know 4 into 6 is 24 plus 1 is 25. Right. So this is followed for any division. This is followed for any division you want. Any division, be it the division of the numbers or be it the division of the polynomials. So if I divide some polynomial, suppose I am dividing a polynomial px with a divisor, let us say dx. This px dx means some polynomial, and the quotient is, suppose let us say qx, and after solving this you got your remainder as rx. So all these are different polynomials. Px is the dividend, dx is your divisor, qx is your quotient, rx is your remainder. Correct? So the same thing will apply here as well, that the dividend is equal to divisor into quotient plus remainder. This bracket x stand for that this polynomial is in the variable x, divisor is also in the variable x, quotient also you are getting in the variable x, and remainder is also in the variable x. Right? Now as in the numbers, the division of numbers, you know remainder should be less than divisor. When you divide algebraic polynomial, when you divide the polynomials, remember in division of polynomials, in division of polynomials, the main thing is that the degree of remainder will be less than degree of divisor. Degree of remainder will be less than degree of divisor. So in the division of numbers, remainder is less than divisor. In the division of polynomials, degree of remainder is less than degree of divisor. Got it? So now let us start your remainder theorem. Let us start your remainder theorem. Remainder theorem. So the first condition to use remainder theorem, remember, first let us understand that it is only applicable. It is not if, it it is only applicable if divisor is a linear polynomial. Divisor is a linear polynomial. That means the divisor should be of degree 1. The degree of the divisor should be 1, because we know a linear polynomial means what? A polynomial of degree 1. So let us say beta I have taken my divisor dx is, let us say, equal to x minus a. My divisor dx is x minus a. So this is my divisor. My dividend is px only. Okay, my dividend is px only, and my quotient is qx, but here I am dividing by the divisor. Divisor is a linear polynomial which is x minus a. Now let us talk about remainder. You know beta that the degree of remainder will be less than degree of divisor. So I got to know that now the degree of remainder should be less than the degree of divisor. What is the degree of divisor? Since it is a linear polynomial, degree of divisor is 1. So the degree of remainder should be less than 1. So we have only one option, that is degree of remainder should be equal to 0. Correct? So the remainder is of degree 0. That means the remainder is a Remainder is a constant number. Constant polynomial means what? All non-zero real numbers, right? So all the rational, irrational except 0, all the numbers will be your remainder. Okay. So the degree of remainder is 0. That means the remainder should be a constant polynomial, or we can say it is a non-zero real number. So instead of writing Rx, since I know it is a remainder, let us just write it as R only, where R is a constant number. So now R is my remainder. R is my remainder. Got it? So first thing what I have told you, you can apply remainder theorem only if your divisor is of a linear polynomial. So divisor you have considered as x minus a. So if you divide the polynomial px by x minus a, your remainder will be of a degree which is less than degree of the divisor, that is less than a degree 1. So degree less than degree 1 is what? Degree 0 only. Degree cannot be negative. So the minimum degree, that is degree 0. So if you divide a px, a polynomial px whose degree should be 1 or more than 1, okay, then the divisor, if the divisor is a linear polynomial, the remainder will be a constant number. The remainder will be a constant number, right? Now let's understand what will happen. So beta, in this division, in this division if I use the formula which is dividend is equal to divisor into quotient plus remainder, so I can say the dividend px is equal to divisor which is x minus a into quotient, sorry, let me just erase this part, into quotient which is into qx plus remainder, and we know r is a constant number. Correct. Now I want to find out R. I want to find out R. So I will try to get rid of this part. I want to get rid of this part. Which part? X minus a into qx. I have to make this somehow 0. How can I make it somehow 0? Beta, I saw, because what is this x minus a? If I put x is equal to a, then let us see what will happen. If I put x is equal to a, you will get p of a. That means value of the polynomial, the value of the dividend at x is equal to a is equal to a minus a into q of a plus r, because r is a constant number, r will not change. So a minus a is what? 0. 0 into anything is 0. So you got pa is equal to r, and this is how you can find out your remainder. So we got to know that if I want to find out the remainder, if the divisor is a linear polynomial, I can say remainder will be equal to the value of the dividend at x is equal to a. What is a? How will you find out what is a? From the divisor. From the divisor. So now, how do you use the remainder theorem? How do you use the remainder theorem? For example, I have told you. Now, again, one important thing I would like to tell you all here, that remember the remainder theorem, if you will see, is only telling me about remainder. You saw that the quotient got 0. Quotient 0 into quotient, so quotient doesn't matter in remainder theorem. So remember, we can only find remainder using remainder theorem. You can only find remainder using remainder theorem. Got it? You cannot find quotient. We cannot say anything about quotient. We can't say anything about quotient. Remember. So if the question is asking only about remainder, then only you will be using remainder theorem. If it is asking about the quotient also, in that case, you have to go for long division method. In that case, you have to go for long division method. Right? Now, let's move ahead and understand how the question will be solved. So the question is, suppose find remainder when x square plus 3x plus 4 is divided by x minus 1. If you divide this x square plus 3x plus 4 by x minus 1, then find out what will be your remainder. So beta, here you will see that this x square plus 3x plus 4 is your dividend, and this x minus 1 is your divisor. So as you saw, but yeah, why I put x is equal to a, because I wanted to make my divisor equal to 0. That was the main part. Here if I make it 0, so 0 into everything will be gone. So first thing you will see that what value of x you have to put, you will get it from the divisor. So the step 1 in using the remainder theorem is make divisor equal to 0 to get value of x. So what I am going to do, but you will do first thing, make divisor equal to 0. So put x minus 1 equal to 0. So you have got x is equal to 1. So this x is equal to 1 is equal to a. Okay, this is that a which you have got in the previous part. So x is equal to 1. Now this value of 1, I will put it in the dividend. So the second step is put value of x obtained in step 1 into dividend px. That means this value of the polynomial, this dividend px, which is equal to x square plus 3x plus 4, its value I will find out at x is equal to 1. So let us do that. So I will say p of 1 will be equal to x square plus, p of 1. So I have to find out p of 1. This p of 1 will be equal to your remainder. This p of 1 will be equal to remainder. Why it will be equal to remainder? Because if you will see here, I have told you that the value of the dividend at x is equal to a. The value of the dividend at x is equal to a is equal to remainder. So I can say that, sir, my remainder will be equal to value of the dividend at x is equal to a, and a for this question is 1. So I will find out x square plus 3x plus 4, value of x square plus 3x plus 4 at x is equal to 1. So it will become 1 square plus 3 into 1 plus 4. 1 square is 1, 3 into 1 is 3 plus 4. So you have got 8. So your remainder is equal to 8. As simple as that. Step 1, make divisor equal to 0. Whatever value of x you have got, that value of x, put it in the dividend. Whatever value of the dividend you are getting at the x is equal to whatever you have got, that value will be equal to your remainder. So this is your remainder theorem. Okay, now let's come to the part of factor theorem. Now factor theorem is very easy, beta, nothing much. This is just an application of remainder theorem. Only factor theorem is what? But beta, suppose if I ask you that 15, write the factors of 15. So you will see, sir, 1, 3, 5 and 15. These are the numbers which are the factors of 15. And how do you know? These are the numbers which are exactly dividing 15. 15 divided by 1, remainder is 0. 15 divided by 3, remainder is 0. 15 divided by 5, remainder is 0. 15 divided by 15, remainder is 0. So all these numbers, when you divide 15 by any of its factor, either 1, 3, 5 or anything, the answer, I will say what is quotient, I don't know, but my remainder will be equal to 0. So the same thing happens for the algebraic expressions as well, or the polynomials as well. That means if you divide a polynomial px by one of its factor, if I divide px by a factor of px, then in this case I will say that my remainder will be equal to 0. Factor of px means if you factorize polynomial, so you'll get something into something. Suppose x square plus 4x plus 4 is equal to x plus 2 into x plus 2. So x plus 2 is a factor of px. So that way, if you divide any polynomial by its factor, the remainder will be 0. So in this question, again you will apply remainder theorem only, but you already know that the remainder will be equal to 0. This is the main part. Suppose the question will be that check if x plus 1 is a factor of x square plus 4x plus 3 or not. Okay, you have to check it. So what you'll do, first thing, sir, I know that if it is a factor, I know that x square plus 4x plus 3, if it is divided by x plus 1, I know that my remainder should be equal to 0. My remainder should be equal to 0. And we already know how do you get the remainder using remainder theorem. So step 1 of the remainder theorem, x plus 1 equal to 0, you will get x is equal to minus 1. And step 2, find out the value of this polynomial at x is equal to minus 1. So I know that my remainder will be equal to what? Here at x is equal to minus 1. So minus 1 square plus 4 into minus 1 plus 3. And I have told you beta remainder should be equal to 0. So I am saying this part should come equal to 0. This part should come equal to 0. If it is coming equal to 0, then it is a factor. If it is not coming equal to 0, it is not a factor. So minus 1 whole square is 1. 4 into minus 1 is minus 4 plus 3. So 1 plus 3 is 4 minus 4 is equal to 0. So you can see remainder is equal to 0. So if remainder is equal to 0, I can say x plus 1 is a factor of x square plus 4x plus 3. Got it? So factor theorem says that if you are dividing a polynomial by one of its factor, remainder should be equal to 0. That is your basics of your remainder theorem and your factor theorem. So remainder theorem, step 1, make divisor equal to 0. Step 2, that value of x, put it in the dividend. And for the factor theorem, if we will divide a polynomial by one of its factor, remainder must be equal to 0. Got it? Let's solve some questions related to it. Question 1. If x square plus 6x square plus 4x plus k is exactly divisible by x plus 2, then what is k? Exactly divisible means I know that my remainder is equal to 0. So they have already provided me with the information that, sir, if you divide x cube plus 6x square plus 4x plus k by x plus 2, your remainder will be equal to 0. Correct? How do you get remainder, beta? First step, x plus 2 should be equal to 0. You will get x is equal to minus 2. And step 2, the value of this polynomial x cube plus 6x square plus 4x plus k. So I will say my remainder will be equal to, put x is equal to minus 2 here in the polynomial, in the dividend. So minus 2 cube plus 6 into minus 2 square plus 4 into minus 2 plus k. And I know if it is exactly divisible, remainder should be equal to 0. So I will say this value minus 2 cube plus 6 minus 2 whole square plus 4 into minus 2 plus k is equal to 0 because it is your remainder. Got it? So this part we will solve to get to get the value of k. So minus 2 cube is minus 8. 6 into minus 2 square. So minus 2 square is 4. 6 into 4 is 24. Then 4 into minus 2 is minus 8 plus k equal to 0. So you are getting minus 16 plus 24 plus k equal to 0. So you are getting 8 plus k equal to 0. That means k is equal to minus 8. As simple as that. Okay, so they have told exactly divisible, so you got to know that the remainder should be equal to 0. Is it clear? So I can say making remainder equal to 0. Remainder I have got using factorize using remainder theorem, and that I have made equal to 0. Let's go for the next question. K is equal to minus 8. Next question is x raised to the power 140 plus 2x raised to the power 151 plus k is divisible by x plus 1, then find the value of k. Now these kind of questions, if you go by long division method, it will take forever, but with remainder theorem it is very easy because they have clearly told that this part is divisible by x plus 1. That means I know remainder is equal to 0. How do you find out remainder? Step 1, divisor should be equal to 0, and as you can see divisor is a linear polynomial, that is why I am using remainder theorem. So you are getting x is equal to minus 1. Now I know beta, second step, that remainder should be equal to 0, and remainder according to this remainder theorem will be minus 1 raised to the power 140 plus 2 times of minus 1 raised to the power 151 plus k should be equal to 0. Now if minus 1's power is even, then answer is 1, and minus 1 power is some odd number, then answer is minus 1. So minus 1's power is even number, so it is 1 plus 2 into minus 1 raised to the power 151, odd number, so it will become minus 1. So it will become 2 into minus 1, which is minus 2 plus k equal to 0. So finally you will be getting 1 minus 2, which is minus 1. So you are getting minus 1 plus k equal to 0. So I can say k is equal to 1. K is equal to 1 is your correct answer. Got it? Let's go for the next question. Next question is, find the remainder obtained on dividing px, which is x cube plus 1 by x plus 1. Now they are just asking you remainder. So either you can use long division method also, or you can use remainder theorem. If they would have asked me the question also, I would definitely use long division method, but now since only remainder has been asked, so better go for remainder theorem. So the step 1, make x plus 1 equal to 0, you will get x is equal to minus 1. Put x is equal to minus 1 in this polynomial, so I will say remainder will be equal to value of this polynomial dividend at x is equal to minus 1, which is minus 1 cube plus 1. Minus 1 cube, odd number is minus 1 plus 1, which is equal to 0. So I can say my remainder is equal to what? My remainder is equal to 0. Got it? Let's move to the next question. By remainder theorem, find the remainder when px is divided by gx, where px is x cube minus 6x square plus 2x minus 4, and gx. So beta px is divided by gx. So this gx is your divisor. So if we have to use remainder theorem, step 1, make divisor equal to 0. So you got 1 minus 3 by 2x equal to 0. So what you'll be getting, beta? By first thing, you can say 3 by 2x is equal to 1. So x is equal to, shift 3 by 2 there, x is equal to 2 by 3. Now we need to put x is equal to 2 by 3 in this dividend. So it will become 2 by 3 cube minus 6 into 2 by 3 square plus 2 into 2 by 3 minus 4. So you'll be getting 2 by 3 cube minus 6 into 2 by 3 whole square plus 2 into 2 by 3 minus 4. 2 by 3 whole cube is 8 by 27 minus 6 into 2 by 3 whole square is 4 by 9 plus 2 into 2 by 3 is 4 by 3 minus 4. So this will become 4, 3 2s are 3 3s are. So you have got 8 by 27 minus 2 into 4 is 8 by 3 plus 4 by 3 minus 4. Now minus 8 by 3 plus 4 by 3 will be equal to what? Minus 4 by 3. So 8 by 27 minus 4 by 3. I have added these two. Minus 4. Now take LCM here. So if you will take LCM here, 27 is the LCM here. So 27 is as it is here into 9 into 9 here into 27 into 27. So you will be getting 8 minus 4 9s are 36. 27 into 4 is minus 108 divided by 27. So 36 and 108 will be equal to 144. 144 and 8 will be equal to 136. So minus of 136 upon 27. Minus of 136 upon 27 will be your remainder. Minus of 136 upon 27 will be your remainder. As simple as that. Okay. The next question is, check whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6 or not. So you have to check that whether x plus 2 is a factor or not. So if x plus 2 is a factor, I know remainder should be equal to 0. So when I use remainder theorem, if remainder is equal to 0, x plus 2 is a factor. If remainder is not equal to 0, x plus 2 is not a factor. So let us do that. Step 1, make x plus 2 equal to 0, because x plus 2 is your divisor and this is your dividend. So x is equal to minus 2. And second step, the remainder I will say is equal to, put minus 2 here. So minus 2 cube plus 3 into minus 2 square plus 5 into minus 2 plus 6. Minus 2 cube is minus 8, minus 2 square is 4, 4 3s are 12, 5 into minus 2 is minus 10 plus 6. So 12 plus 6 is 18, minus 8 minus 10 is minus 18. So you can see that the remainder is equal to 0, and if remainder is 0, I can say x plus 2 is a factor of this part, x cube plus 3x square plus 5x plus 6. Got it? So remainder, this factor theorem is nothing but just one small step ahead, that if something is a factor of a polynomial, the remainder should be 0 in that case. As simple as that. Next question. Find the value of k if x minus 1 is a factor of 4x cube plus 3x square minus 4x plus k. Now they have already told that x minus 1 is a factor of this. X minus 1 is a factor of this part. Okay. So I know in this case remainder should be equal to 0, must be equal to 0. So let us make remainder 0 and find out the value of k. So step 1, x minus 1 equal to 0, you have got x is equal to 1. And step 2, I know that my remainder will be equal to 0. So what is your remainder? Put x is equal to 1 in the dividend. So 4 into 1 cube plus 3 into 1 square minus 4 into 1 plus k equal to 0. So I've got 4 plus 3 minus 4 plus k equal to 0. This to this got cancelled. You are left with k is equal to minus. Got it? As simple as that. So the remainder theorem and factor theorem are very easy sessions. These are just the basics. Please revise all these questions one more time. Go back to this video, check your solution one more time. After that, once the video is done, please note down the questions, stop at the point, solve this question on your own and check whether you have got the same answer or not. Solve the other question as well, so that when I come with the second session where I'll be discussing very good problems, there you will not feel any difficulty. Got it, beta? So this is all. Again, once again, I would like to tell you all this news, that all those students who are out here, if you have not downloaded the Vedantu app yet, please download it, because now there is a live online quiz on that app. And if you perform in that quiz, you can earn money up to rupees 50,000, and that is you can get it from Paytm cashback. Okay, sorry, that is get Paytm cashback also. So remember this thing, very important part, earn and learn. Got it? So don't forget, don't miss out on this chance. Got it? And also all the courses for Vedantu are free right now. So to know more about it, go to the link vdnt.in/ytlive. And then we said beta, absolutely free. First thing, no registration fee. Second thing, give the exam at the comfort of your home. And third thing, get scholarship. What else you want? So register to this link for registration for VSET, vdnt.in/ytvsat. Got it, beta? So this is all from my side in today's class. I hope all of you enjoyed today's session, and I'll see you soon in the next session. Next session is going to be very interesting question from the following topic. So make sure you don't miss out on that. Okay, beta? So with this, I'll sign off for today. Take care, stay safe, stay at home, and earn and learn. Okay, don't forget to download the Vedantu app. Don't forget to leave the like before leaving the video. Thank you so much. I'll see you soon. Bye bye. Yeah, chalo. Bye bye.